Test, test. We're good. All right. What's up, everyone? Welcome to week 5 of Intro to Backend. So all of the major coding is done for this part of the class. So you've basically gotten through the hard part of the class. Now these next 3 weeks are going to be pretty chill. I'm just going to be covering some topics covering containerization, DevOps, and just some other cool things in the next 3 weeks. So today is going to be containerization. So a few announcements. PA2 grades were released. If you had an issue about how your assignment was graded, please email the person who graded you. Their name and net ID can be found at the top of the I guess file that's included in CMSX with your submission. PA4 is due this Wednesday, November 8th. And now we have in-person office hours now. They were previously on Zoom, but we finally got approved for some rooms. So an ed post was made about it, I think either yesterday or today. But yeah, they're now in person. So if you have any debugging issues, make sure to swing by office hours and the TAs will be able to help you. So yeah, for course overview, we've done routes, databases, relational databases, and abstractions. And these 4 things kind of allow you to have like a core backend. And the next half of this course is going to be how to kind of get this backend to not only run locally on your computer, but have other users run it as well on their computers and stuff. So this week, we're going to be covering containerization and DevOps. So first is a quick review. Last week, we covered ORMs. And so ORMs use objects and classes to interact with the database. And so remember how in our tasks and subtasks models, we represented them as classes instead of as actual models. And so what this allowed us to do is that we didn't have to run stuff in raw SQL code. The ORM, which we used, was SQL Alchemy, and that kind of did all the hard work for us. And it just made all the syntax, running all the code much easier and just much more readable, which is really nice. So in ORMs, the class corresponds to, I guess, the table. So we had a task table in previous demos, and last week's we had a task class. Same thing for the subtasks. It was a table in the demo 2 weeks ago, and the demo last week, it was a class as well. Like I said, ORMs translate SQL to Python, which makes it a lot more readable for the user. And it automatically handles enforcing reference conditions. So remember how we had, auto increment equals true. We could just flag those things as true and false, and it just made it a lot easier and much more readable. And it also handles manipulating join tables. So inserting stuff, adding stuff, deleting stuff. The ORM handles this for us, which is really nice. So next, we're going to be talking about the deployment process. So first, we're going to do dev versus prod environments. So the dev environment is short for development, and it's an environment that engineers write your code in. So this is kind of like our app.py and db.py files. And this contains print statements, other debugging logs, and just other testing, I guess, things in general. And then the next thing is the prod environment, and this is short for production. And this is the environment that your users interact with. And so since your user is interacting with this, you want it to be, clean, error-free, and you just want it to be really nice for the user. So, yeah. And so now we're going to get to the deployment process. So it's composed of 4 kind of big steps. And this week, we're going to cover the first 2 of them. And so the first part is compressing code into a production environment. And the second part is preparing the production environment to be run ready. So first of all, how do we run apps on other machines, right? So for the first 4 weeks of this class, we've been running stuff locally on our computer, just doing 3 things, installing Python, installing the requirements, and then just simply running it on our computer. But how do we actually get other people to run our code on their computers? How do we kind of ship it to them? What's a good way in order for them to be able to run our code? So before we answer this, we need to think of why do such a thing, right? So in production, we don't want apps to be running off our local machines. So you all know about Eatery. Eatery is the dining hall app where you can see all of the food that's in the dining halls, right? So let's say Eatery is running off my local computer, right? And it becomes nighttime and I fall asleep and I close my laptop, right? Then Eatery is down because my laptop's not working, right? So then let's say I sleep into like 5 p.m. or something. That means eatery is down until 5 p.m. So people won't know like what's for breakfast, what's for lunch in all of the dining halls. So instead, we need to be running kind of our apps on like other machines that are also servers, right? So that when I close my laptop, like the server just doesn't shut down, right? We have to have like some sort of server, running like at all times so that our app doesn't kind of, shut down. So yeah, so we're going to explain what's an environment. So there's 4 kind of components to an environment. So first is the operating system. So like Mac OS, Linux, or Mac, Windows, Linux, whatever your operating system is. And then the second part of the environment is your code. So our environments previously were just our app.py and db.py, the files that we were writing our code in. And the third thing is the libraries, and these are kind of the tools and dependencies that you use to run your code. So or in our case, this was the requirements.txt file. We use those kind of libraries to actually run our code. And then the last thing are these environmental variables, which we'll touch on in a second. So yeah, like the operating system is Mac OS, Windows, Ubuntu. Our code is our app.py, db.py. The libraries are requirements and also Python. And then we're going to talk about environmental variables in a second. So yeah, so environmental variables are basically like sensitive information in our source code that we don't want to be sharing with other people, right? So let's say you have like username and password combinations that you need to log into like a certain database, right? When you push your code to GitHub, you don't want everyone to see like what your username and password is to log into this server, right? So the way that environmental variables work is that you define them within like a local .env file. And what this does is it basically like hides them from, I guess, any users who are looking at your code, and it's only visible to the implementer, which is really nice. And so after you define them in the env file, you SSH into the server and create the same .env file. And so doing that, only the implementer is going to be able to see the environmental variables. But if you have this like public on GitHub, people who are looking at your repo won't actually be able to see what your environmental variables are. So here's a quick example. So we see that over here, we're trying to, I guess, connect to some sort of database, right? So we have our host is just our local host. The database is Ithaca Transit, which was like a previous app dev app, which is like telling everyone about bus routes and stuff like that. The username is SN685, and the password is super secure password, right? So this is right here. This is in some like app.py, db.py file, right? I think it's in our app.py. So if you push this to like GitHub like this, then everyone will be able to see like what these variables are, or like what the values of these variables are, right? So then anyone can come like into your GitHub, see this stuff, log into your database, and then just edit some things randomly, right? So we don't actually want that. So the way we use environmental variables so we have this .env file over here, right? And so we kind of have our environmental variables of database, username, and password kind of stored in this environmental variable file, so that people who are looking at, I guess the users who are looking at this file can't actually see what these are, and it's only visible to the implementer. So we see that our database name is Ithaca Transit, the username is SN685, and the password is the same password as on the left. And so after defining this .env file, we modify the left side of the code as so. So we see that we have database equals os.environ database, right? So the client, or I guess the user, when they're looking at your code, right, they're going to see os.environ database, right? But they don't actually get any like useful information from that, right? They just see that this is referencing some sort of environmental variable, but they don't actually know what the value of this environmental variable is, right? So we see that database is referencing the database variable in the .env file, and same thing with the user and also the password. And so, yeah, so we have a .env file in our computer, and we also have yeah, so we have our .env file in our local computer, and then we would create this exact same file on our server. And then, so basically we only want the environmental variables to be available to those using the server. And it should not be public, I guess, general information, right? So this is, I guess, the cool thing about environmental variables. All right. So I guess like with regards to the course, we've been taking like a small scale approach, right? So I mean, the three things that we do when we kind of run an app are we first install Python, we install requirements.txt, and then we actually run our app.py, right? And this kind of works for simple applications, right? So like the task app, the to-do app, like all this stuff, it's like pretty simple. So it's just fine running it off your local server, right? But let's say you wanted to, I guess, run a larger application, right? So let's say you want to run Ithaca Transit, for example. Ithaca Transit has a ton of dependencies that aren't installed in your computer. It could be using a different database that we were using in the past. So we've been using SQLite3, right? They could be using Postgres or MongoDB or something else, right? So yeah, there's just a lot more custom package installations involved. And so you would have to manually like isolate environments and for like every, I guess, time you're running this larger application, right? So this setup becomes really cumbersome. And so we want, I guess, a modular and automated solution to, I guess, run our applications or run our larger applications a lot faster. So the old way to do this was through virtualization. And so to do this, you would use virtual machines. So with virtual machines, you're basically like running a computer within another computer. So like, let's say you have a Mac, right? And the app that someone wrote was on a Windows, right? So what a virtual machine would do, it would kind of install the Windows dependencies on your Mac, like within a certain environment, and then you would like run that on your computer. And so, yeah, it allows us to set like an operating system to run. So in that case, like in the example I just gave, you would set up the Windows operating system on your Mac to run it. And so, yeah, so it's sandboxed from our host computer's files, and then it can run a lot of multiple simultaneously files on the same computer. But the problem is that, so we see here, we have 3 apps over here running on the same, I guess, hypervisor and then the same infrastructure, right? And so the problem with this is that it uses a lot of space and also just time complexity. And it's not the most efficient way of like doing this stuff. So I guess the solution to this is containerization, which is kind of the main theme of this lecture. So containerization, again, it compresses code into a production environment, and then it prepares the production environment to be run ready. Yeah, so the first step of this is to compress code into a production environment. And so to do this, we need something called Docker. And so Docker is basically a cloud-based platform that basically so containerization is basically putting your app into a very, I guess, tiny, neat container. Tiny container that basically modularizes it and allows it to develop a package it allows developers to package their code into a standard unit of software. And Docker, I guess, allows us to do that, right? So it allows developers to package code into a standardized unit of software, and it builds kind of the code that we've kind of written into images. And then after that, it runs an image as a container, if that makes any sense. So what a Docker image is, it kind of builds images from your source code. So like, yeah, it basically is a blueprint for your app. So if you build an image for your source code or define what you want your app to look like in a file called Dockerfile, So you build an image for your source code or define what you want your app to look like in a file called a Dockerfile. And then you create your Docker image that's essentially kind of the blueprint to what your app would look like. So the way to think about like a Docker image is like a blueprint for like what your app actually is. So I'll skip to this. So images to containers in like Docker are like classes to objects, I guess, in Python. So like in Python, the classes are like a blueprint for like what you want an instance of your object to be, right? So the image, again, is kind of like a blueprint of like what your app looks like, right? So, and then again, like blueprints and houses, you have like a blueprint for your house, and then you actually like build your house, right? So it's the same thing for like images and containers. And so going back to containers. Yeah. So the containers are kind of a live instance of your application. And they define running instructions with additional flags. So like when you run a container, it's like Docker run, and then to see all the containers, do Docker PS. So basically like the container, you run it from an image. So essentially like the image is your blueprint, and then you run the container from your blueprint. So you're kind of creating an instance of your app from this blueprinted image that you've just created. And so, yeah, these are the analogies between images and containers. Okay. So yeah. Yeah, so here's an example of like a better solution to running apps on someone else's local environment. So previously we had virtualization, but here using containerization with Docker, we have a user's operating system over here, and they have Docker installed on it. And on top of that, they also have separate apps running over here. So the good thing about this is that you don't actually have to install every single like other person's like dependencies and dependencies and operating systems. By just having Docker over here, you can just run a lot of apps simultaneously, and it's a lot faster and a lot easier for the computer to do so. So yeah, so instead of like having to install the virtual machine that has different operating systems and stuff like that, we just install Docker, and then Docker does all the work for you using those containerized applications. So yeah. Some benefits of Docker are that it's very simple and it's a standardized way to deploy your apps. So it's kind of a better application management system. It also requires like fewer resources and less time and less space. So yeah, and then it boots the application up faster since it requires less time. And all this kind of leads to simplification and modularity, which is kind of the goal of like DevOps in general. So yeah, so then the second step is to prepare the production environment to be run ready. So to do this, we'll be using something called Docker Hub. So Docker Hub is really similar to GitHub. In GitHub, you push code to a repository, and if this repo is public, then anyone can see your code, right? So it's really similar to Docker Hub in the sense that Docker Hub is a cloud-based service, and it stores your Docker images, right? So what you'll do is if you create a Docker image in your code, you can push it to Docker Hub. And then if this image is public, then anyone can see this, right? So it's pretty similar to GitHub in that sense. So I guess this analogy over here like explains this pretty well. So the code that you push to GitHub is analogous to the image that you push to Docker Hub. And so I guess this is like a necessary medium for remote servers to access pre-built images, right? So anyone, I guess, on the internet can go to Docker Hub and kind of see your public images and is able to take those images and then eventually run it on their computer. Okay, so I guess the steps to actually like push an image to Docker Hub are, so you first create the Dockerfile, which basically defines like what you want your app to be like. And so after creating your Dockerfile, then you're going to build an image. So when you build this image, it's kind of like a blueprint for what your app is actually doing. So you've defined what you're doing, I guess, with the Dockerfile, and then you build the image, which is like the blueprint of what you did. And then after you build this image, you push the image onto Docker Hub. And then if someone wanted to pull this image from Docker Hub, you just do Docker pull. Pretty sure there's a command for that. You pull the image from Docker Hub, and you can create many instances of your app, because remember, the image is like a blueprint, and then the container, the Docker container, is a live instance from your app, right? So people can pull, a lot of people can pull many images from, I guess, this one image, right? And they can run many instances of your app by creating many containers of this image. And so that kind of explains like the multiple whales over here in a sense. So like you have one image and you're pushing this image to Docker Hub, and then many people can pull, this image and create many live instances of your app on their computers. And so Docker Compose is kind of like a tool to do this. So it's a tool for defining and running multi-container Docker apps. For the purposes of this class, we're only going to be using apps that require one container. But Docker Compose is just like a good thing to know if you're going to run multi-container Docker apps. To do this, you have to create a Docker Compose YML file to define the application services. And yeah, this course just works with one container. And so I guess Docker Compose is like kind of explained by this analogy right here. So you have the octopus and it's kind of juggling all these like different containers, right? And these different containers are like the dependencies that you have, right? So you could be using Python, Postgres, whatever other like applications you're using. And then it kind of composes them into one like entity over here, which is represented by the whales over there. And so, yeah, just a quick summary of what we've gone over today. I know I just went over a lot of stuff like really quick. So does anyone have any questions? All right. Yeah, so for summary, you first, I guess, define a Dockerfile to specify an app's like required environment. So again, the Dockerfile is like defining what you want your app to actually do. So after you create your Dockerfile, you build a Docker image. And so that is kind of a blueprint for your app. And then after you create this Docker image, you push the image to Docker Hub. And if you set this to public, then anyone can see the image that you just built. And then you can define how to run your images in a Docker Compose file. And so now we're going to spin off a little bit into DevOps. And so DevOps is kind of composed of like two terms. So first is development, which is like building software, which is what we've been doing with our app.py and db.py, creating all these, to-do apps and, Venmo stuff for the assignments and all of that. And then operations is actually testing and releasing software, right? So DevOps is kind of the boundary of where these two meet. The goal is to build and ship software quickly and reliably. And so this makes development and operations like float really seamlessly, which is really good because if you're trying to, ship a lot of software, really a large amount of software pretty fast, having good DevOps is, just good in general. And so this kind of explains like the analogy of, or I guess this explains what DevOps is. So you technically start with this plan step over here. So like you plan what you're going to do, you create it, you verify your software, you package your software, which is kind of like building your Docker image. You like package it, then you release it, you configure it, you monitor it, and then you go back to plan. And then that's kind of like the cycle of DevOps in here. And then, yeah, now on to the demo. Does anyone have any questions? Yeah. Yeah, it's basically a blueprint for like what your app is essentially. So you can think of it as like, so remember the container is like the live instance of your app, right? So what you do, so if you compare images to containers, it's like having like a blueprint for your house and then the actual house that you've built, right? So the image is kind of like a blueprint of like what you're going to run. And then the container is like what, like the actual instance of like you running it. That makes sense. Yeah.
All right, so now we're going to go into a pretty short demo. So since we only have a little bit of time left, we're going to start just by making a Docker container locally. So I'm gonna leave this. There's this. So right now I have just starter code from, I think this is PA4. I go to app.py. I have tasks. So this is from a demo 4. The code itself doesn't really matter, but we're just going to show off how you can package into a container. So first thing, let me clip this on so I can type it. Okay, so right now we're here. So like before we said, before you can make a container, you need to make an image. Before you can make an image, you're going to need a Docker file. So let's start off by making a Docker file. So to do that, you can just make a new file using VS Code, call it Dockerfile. And it has to be with a capital D, so I believe. By doing that, you just have a blank file. Close off some of these. So we want to make an image, or we want to end up making a container that has a pretty similar working like virtual operating system to what we have now. So we can start out by making our base image from Python. So if you say from You can say then Python. And you can give it a version. This is going to be pulled, I think, from Docker Hub or somewhere. So it doesn't have to be your version of Python. So I could just say like, well, I'm going to use my version. So I don't actually know the specific versions that there are. So if you do Python version, or let's see this Python 3 version, right now we have installed 3.10.5. So I'm just going to use 3.10.5 for the version. Now we can say run. And when you say run, it runs a command in like the shell when creating the image or container. And you want to make a new directory called user/app. And we want to have like our code live in this directory in our container. So we can say work directory, and we can say user/app. So the work directory will make our current working directory in the container this file path. So now we want to be able to copy. And so what copy does is like copies the code from here into a specific location in your container. And since we have our code here, we can say copy dot to take it from our current location. And we can put in the destination in the container. And since our working directory is user app, and we want to put it there, we can just say dot again. So we're taking it from our current directory and putting it into our work directory by just saying dot dot. Next, we want to run what we usually run. We have like a virtual environment, pip3 install our requirements .txt. And this will just install the required modules onto our container since we have copied the requirements.txt into our container. And then we're going to run command, and this is going to run our actual software, so app.py. So command is just like run, but you can only use it once in the Dockerfile. So you usually like use run to set up your Dockerfile with like other commands, and command cmd will be like the final thing that actually runs what you're containerizing. So we make a directory, we set ourselves to work in that directory. We copy our code from this location to user app. Then we install our requirements, and then we run our code. So that's just kind of how you make a blueprint for creating your image, which is a blueprint for creating your containers. And now we have to also create one more thing. So imagine that I've been working on this code for a while. That means I probably have a virtual environment. Oh, Python 3. And as you guys might know, it's usually bad to have your virtual environments be like saved anywhere else because it tends to be a pretty big file. And if you want to make a container of your code, you don't want to include your virtual environment, right? Do you have a question? Or I don't know. Yeah, so we don't want to include our virtual environment in our actual image. So the way you actually get rid of it is using a dockerignore file. So dockerignore like that. And it's almost just like a gitignore file. You just type in the things you want to remove. So I want to remove the vend directory from my image. And if I were to run this Dockerfile, it shouldn't show up in the actual image. So that's one thing you usually want to do. And now let's actually create our image. So as you've seen today, you can just say Docker, and then build, and then you can say the location of the Docker file. And this is going to be the current location, right? So it'll just be dot. So Docker build dot, and it'll start building our local directory. Oh, seems to be an issue. Repository name must be in lowercase. Oh, I guess it has to be in lowercase. So make sure this is in lowercase. Let's try that again. And it'll go through the motions, running our command that we talked about in the Dockerfile. Like see, it did run, work dir, copy the code, started running our requirements.txt or pip install on requirements.txt. And then it created the image. So if I do Docker images, this will show me all my images, and there are a lot in here, but this is the newest one. It was created 13 seconds ago, and that's the one we just made. And it has an image ID, but as you can see, it doesn't have like a repository or an actual tag. This is completely fine. So since you can just like use the ID to reference this image, but if you want to like make it easier to share or push it to Docker Hub, you're going to want to have a repository and a tag next to it. And the way you can do that is by building it in a similar way. So saying Docker build, but this time you say -t, and now you can write your repository that you want to use. So let's say Tony/demo5 is my repository. And then you can say colon, and now you can tell your tag, or I guess newest. Ooh, did I miss something? Yeah, I missed a dot. So you still need a dot so that you can tell where the Dockerfile is. So to reiterate, this is the repository, and this part is the actual tag. And once you rebuild it, you do Docker images. You can see here that it now has a repository, now has a tag, and it was rebuilt. But most of the information that was built was actually cached from the last time I built it. So it was much faster this time. And typically building images does take quite a bit of time. So now let's actually run the image and make a container. So make command click this. So to run it, all you need to say is Docker run, and you can maybe actually bring it back. Oops, that's not what I meant to do, but it's fine. Docker images. You can use it with the image ID or the repository plus tag. So if I say Docker run, and then I just put in the ID, it's gonna happen. There's a issue with the actual code that we have. It's annoying. Here for collections. This is in here. Let me see this real quick. Yeah. Normally, I don't think that should happen. Something wrong is with the actual demo code. Let me like do something real quick. I'm gonna get rid of all of the DB stuff since the actual code here doesn't really matter. We just want to have the server running. So I'm gonna get rid of all of this, all of that, and just I'll keep Flask, but yeah, there we go. Now I'm gonna rebuild it. This will take a little bit more time since I've actually changed the code, but shouldn't take too much time. I didn't delete too much stuff. Oh, I did delete too much stuff. What do we need here? We don't want this. Oh, it's fine. Get rid of this. Get rid of all the routes. I'll keep this route. Actually, it should be fine. I'm gonna test it out locally. So Python 3 app.py. Save it and run it again. That works locally, so usually good to test out if your code works before you containerize it. So now I'm gonna run the image again. Or I'm gonna build the image again. This will take a few minutes. So does anyone have questions yet? The Dockerfile gives instructions on what to do to build the image. Yeah, but it's not the image itself. It's just like an instructions for the instructions. Anyone else have any questions? Yeah. I guess like the virtual machine is like the whole operating system, but this is just like a mini operating, not even really operating system, just like running on like a virtual. It is like a virtual operating system kind of, but it's mainly for like one process to run on so that they can have isolated places to work. Yeah, still going. So, okay, there we go. Docker images. I'm gonna copy this image ID, Docker run this. Oh, weird. It seems like, oh, so it wasn't actually with the works there. Yeah, unfortunately, it seems like there's just like an issue with this module specifically that is required. Let me try it one more time. Weird, because it was working on my other laptop. We can try it there. If this doesn't work, if this doesn't work, we'll move it over to the other laptop. Still building. Yeah, I think it's done. This doesn't work, we'll probably just like run some other image that's not built in this. Yeah, it's so weird. Let's just try running another image that's just here. Okay, so I just ran another image that Tony just happened to have here open. I think it's like from a previous assignment from last year. And as you can see, it started running that student's web server from Flask, and you can see their IP there. And yeah, so let's try actually connecting to their thing. And one thing to notice is that this actually won't work. It won't let us directly connect, since this Docker is actually, this container that's running right now is isolated from our actual computer. So we can't connect to the server. And we can't even turn it off with Control C. So if I try to Control C, I can't turn it off. So the way you do that is do Docker PS. And Docker PS is kind of like just the normal command PS. It just lists all the processes that are running in Docker right now. And these are containers. So you can see here we have one container that we just ran. And we want to kill, if we want to kill the container, you can just say Docker, I think it's Docker kill and the ID. And now the container stops. So how do we actually use Docker and its containers to actually use as the web server or any other program that's isolated? First, let me go back here. So what you can do is if you go back to Docker images, let's say I want to actually use a repository and tag. So I want to copy these real quick, or just this. You can actually say Docker run. And the difference this time is that we're going to specify a port that this Docker container is going to connect to our actual computer with. So by saying -p, you can say like port 5000 on our local computer is going to reference, let me check which port they're using, port 8000 in a Docker container. So this means that the port 8000 in a Docker container that's running the web server is going to get forwarded to port 5000 outside of the Docker container and on a computer. So if I go to like localhost 5000, I should see it. And then that can honestly be anything, well, almost anything. So I could say 8,000 to 8,000. I can say like 5,001. I'll just leave it 5,000, make it different. And then you also want to say dash IT. This will turn on interactive mode. And then we're going to want to reference the actual container. And I want to do this via the repository and the image tag. Also, one thing to notice is that latest is like the default image tag. It's not the latest one that shows up. So if I run that, now it's running again. And if I go to this link, actually not this link, but if I go to this link on the 8,000 port, still won't work because I've actually exposed the 5,000 port. So if I go to the 5,000 port, now I actually see my web server and it's on a Docker container. So that's pretty cool. And if you want to close it out, since we're in interactive mode, you can just say Control C and it just shuts off. So that's one way to run a Docker container that you build. And I think on Wednesday, we're going to talk more about Docker Compose and another way we can actually run containers. So yeah, let's get into the Kahoot.